Bales of raw wool arrive at the factory gates, compressed and bound for the felting process that requires no spinning or weaving to create fabric. Steam-powered fulling mills pound the prepared fibers with mechanical hammers, compressing and interlocking them through relentless percussion that transforms loose material into dense felt. Heavy hydraulic presses apply tremendous force to layers of prepared wool, binding fibers together through pressure alone without any thread formation. Workers monitor chemical treatment tanks, where acidified water helps the wool fibers lock permanently into the interwoven structure that defines felt fabric. Inside this steam-powered felting factory, compressed wool fibers begin their transformation into felt through mechanical force, moisture, heat, and chemical treatment, rather than traditional spinning and weaving processes. If you can leave a like and subscribe to the channel, it really helps this project continue bringing content about historical industrial processes. Thank you for watching. Now, back to the video. Raw wool arrives daily at the factory receiving area, delivered in compressed bales from farms and wool merchants throughout the region, where sheep provide the primary fiber source for felt production. The wool used for felting requires specific characteristics, with medium to coarse fibers, providing the necessary structure for mechanical interlocking that spinning would actually impair rather than improve. Workers unload the heavy bales from wagons, checking documentation that identifies wool grade, origin, and the degree of cleaning already performed at shearing facilities. Each bale is inspected for moisture content and contamination, as excessive dampness promotes rot, while dirt and vegetable matter would create defects in the finished felt. The receiving warehouse fills systematically with organized rows of wool bales stacked according to fiber length and quality, to ensure proper material selection for different felt grades, ranging from industrial to premium hat felt. This raw wool retains significant natural lanolin and dirt from the sheep, requiring thorough cleaning before the felting process can begin effectively. Before felting can commence, the raw wool must undergo intensive scouring to remove lanolin, dirt, and other contamination that would prevent proper fiber interlocking during the compression process. Workers load wool into large scouring vats filled with heated water and mild alkaline solutions that dissolve grease and loosen dirt embedded in the fiber masses. The scouring process involves multiple baths with progressively cleaner water, each stage removing additional contamination until the wool emerges relatively clean and free of the heavy lanolin coating that inhibits felting. Mechanical paddles or rotating drums agitate the wool during scouring, ensuring solution penetration throughout the fiber mass rather than just surface cleaning that would leave internal contamination. The scoured wool is then rinsed thoroughly with clean water to remove chemical residues that could interfere with subsequent processing or cause skin irritation in finished felt products. After rinsing, excess water is removed through mechanical squeezing or centrifugal extraction, leaving the wool damp but not saturated before it proceeds to drying or direct processing while still moist. This scouring stage is essential for felt production, as any remaining grease would prevent the fiber interlocking that occurs only when clean wool fibers can grip and bind to adjacent fibers under pressure and agitation. The cleaned wool now undergoes carding, though this process differs significantly from textile carding because felt production requires specific fiber arrangement rather than the parallel alignment needed for spinning. Carding engines feed the scoured wool through rotating cylinders covered with fine metal teeth, separating individual fibers and creating a light, airy web of material with random fiber orientation. This random orientation is actually desirable for felt production, as fibers pointing in multiple directions create stronger interlocking when compressed compared to parallel fibers that would simply slide past each other. The carded wool emerges as a thin, translucent web that workers layer systematically to build up the thickness required for the intended felt product, with each layer oriented differently to maximize multidirectional fiber arrangement. Multiple webs are stacked into thick bats, creating the layered structure that will be compressed and worked into felt through subsequent mechanical processing. These prepared bats represent the compressed fibers mentioned in the title, ready for the transformative processes that will bind them into solid felt fabric without any spinning or weaving operations. The prepared wool bats now enter the wet felting stage, where moisture, heat, and mechanical agitation begin the fiber interlocking process that creates felt's characteristic dense structure. Workers saturate the bats with hot water containing soap and dilute sulfuric acid, chemical agents that help wool's natural scales open and grip adjacent fibers more effectively during compression. The acidified water treatment causes the wool fibers to swell slightly and become more receptive to interlocking, a chemical assistance that dramatically accelerates the mechanical felting process. Bats are placed on moving belts or in rotating drums, where mechanical agitation causes fibers to shift, tangle, and begin binding together as the wool's natural properties encourage mutual gripping. This initial wet felting creates preliminary cohesion within the bat, transforming loose layered material into a more unified mass that can withstand the aggressive mechanical treatment ahead. The combination of moisture, heat, chemical treatment, and agitation replicates natural felting processes, but on an industrial scale with controlled conditions that produce consistent results, impossible through traditional hand felting methods. Steam-powered fulling mills now receive the preliminary felted material, their massive mechanical hammers representing the primary force that will compress and densify the wool into finished felt fabric. These impressive machines contain multiple heavy hammers mounted on rotating drums, each hammer lifting and falling repeatedly to pound the felted material with tremendous force. The hammers strike the wool hundreds of times per minute, compressing fibers together while the material is continuously repositioned to ensure even treatment across its entire surface. This mechanical fulling process mimics the traditional hand fulling technique of pounding wet wool, but with vastly greater force and consistency than human labor could achieve. Workers feed the material through the fulling mill repeatedly, with each pass further compressing and interlocking the fibers until the desired density and thickness are achieved for the specific felt grade being produced. The rhythmic pounding creates characteristic industrial sounds that define the felting factory. The percussion echoing through brick halls as mechanical force transforms loose fiber bats into increasingly dense textile material. Steam power drives these fulling mills continuously, maintaining the relentless hammering action that would exhaust human workers within hours, but which machinery sustains throughout entire production shifts. Following fulling, the partially compressed felt undergoes treatment in heavy rolling mills, where tremendous pressure completes the fiber bonding and creates the smooth, dense surface characteristic of quality felt fabric. These rolling mills consist of massive iron or stone rollers weighing hundreds or thousands of pounds, applying pressure that would be impossible through manual methods. The felt passes between these heavy rollers repeatedly, compressed further with each passage as the accumulated pressure forces remaining air from the material and locks fibers into their final configuration. Workers adjust roller pressure and spacing according to the felt grade being produced, with industrial felt receiving maximum compression while softer grades for garments require gentler treatment. The rolling process also begins smoothing the felt surface, crushing down any fiber projections and creating the characteristic finish that distinguishes machine-made felt from the rougher texture of hand-felted material. Multiple passes through progressively tighter roller settings gradually achieve the desired thickness and density, with workers continuously monitoring the material to prevent overcompression that would make the felt brittle or damage its structure. If you'd like to support the channel, leaving a like and subscribing makes a real difference in keeping this space focused on high-quality historical content. Thank you for your time. Let's continue with the process. The compressed felt now undergoes controlled shrinking in steam-heated chambers, where moisture and heat cause the material to contract uniformly, further increasing density and binding strength. Workers carefully control temperature and exposure time, as excessive shrinking would make the felt too small and rigid, while insufficient treatment leaves the material inadequately compressed. This shrinking stage represents critical quality control, transforming the relatively loose material emerging from rolling mills into the tight, dense structure that gives felt its strength and dimensional stability. The steam treatment also helps set the felt's final dimensions, reducing subsequent shrinkage that would occur if this controlled process was skipped and allowing manufacturers to produce felt meeting specific size requirements. Following shrinking, the material undergoes neutralization treatment, where soda ash or similar alkaline solutions counteract the sulfuric acid used earlier, preventing gradual degradation that acidic residues would cause over time. This chemical neutralization is essential for felt longevity, ensuring the finished product maintains its properties through years of use rather than slowly weakening from internal chemical damage. The neutralized felt returns to heavy rolling equipment for refulling, a final compression stage that sets the finished density and surface characteristics before drying and final processing. This refulling employs even greater pressure than initial rolling, compressing the shrunken felt to its ultimate density and creating the smooth, hard surface required for premium felt applications. Workers monitor felt thickness constantly during refulling, adjusting pressure to achieve precise specifications for industrial felts, hat felts, or specialty applications requiring exact dimensional tolerances. The refulled felt emerges substantially transformed from the fluffy bats that entered the process hours earlier, now presenting the characteristic dense, smooth appearance of finished felt fabric. This material demonstrates dramatically different properties compared to woven fabrics, with no visible thread structure and a solid, uniform composition throughout its entire thickness. The compressed felt now requires thorough drying before final finishing, with moisture removal essential for dimensional stability and preventing mildew growth during storage and transportation. Drying occurs in heated chambers with controlled airflow, gradually removing moisture without rapid temperature changes that could cause uneven shrinking or surface cracking. Workers arrange felt pieces carefully during drying, supporting them to prevent sagging or distortion, while moisture is removed and the compressed fiber structure stabilizes in its final form. The drying process requires several hours depending on felt thickness and density, with heavier industrial felts requiring extended time to drive moisture from their thick, compressed structures. Following drying, some felt grades undergo final pressing in massive hydraulic presses that apply tons of force across the material's entire surface, creating perfectly smooth finishes and exact thickness specifications. This final pressing represents the ultimate compression stage, maximizing felt density and creating the glassy, smooth surfaces required for precision industrial applications or premium hat manufacture. The finished felt undergoes careful inspection, where workers examine surface quality, thickness uniformity, and density consistency to ensure material meets specifications for its intended application. Any imperfections are identified and marked, with minor defects sometimes repairable through additional pressing, while severe flaws require material downgrading or rejection. Felt thickness is measured at multiple points using precision gauges, verifying that compression achieved the target dimensions and that thickness remains consistent across the entire piece. The inspected felt is then cut to standard sizes or customer specifications, with sharp rotary cutters slicing through the dense material to create pieces ready for industrial use or garment manufacture. Edge trimming removes irregular borders and creates clean, straight edges that facilitate subsequent processing by felt users and manufacturers who will incorporate the material into finished products. The finished felt pieces are prepared for storage and shipment, wrapped in protective paper or cloth to prevent surface damage and contamination during handling and transportation. Each finished piece receives labeling indicating felt grade, dimensions, density, and intended application to facilitate proper selection by customers purchasing material for specific purposes. The storage warehouse accumulates substantial quantities of finished felt in various grades and thicknesses, representing inventory ready to supply industries ranging from piano manufacturing to industrial machinery, where felt serves as gaskets, padding, and vibration dampening material. Factory records document production from raw wool through finished felt, tracking material quality and maintaining accountability that enables quality investigation if problems arise in the field. The scale of production demonstrates industrial capability with steam-powered machinery and systematic processing, producing felt volumes impossible through traditional hand methods that dominated before mechanization. Thousands of yards of finished felt accumulate through continuous factory operation, representing manufacturing capacity that supports diverse industries whose operations depend on this unique textile created through compression rather than weaving. The systematic felting processes transform raw wool into specialized material, possessing characteristics impossible to achieve through traditional spinning and weaving, creating dense, uniform fabric without any thread structure. Workers prepare finished pieces for shipment to destinations throughout the industrial world, loading carts bound for manufacturers who await material for applications ranging from industrial components to fine hats and garments. Quality and consistency define this industrial production, where mechanical compression and chemical treatment create standardized material far superior to the irregular hand-felted products that preceded factory methods. Inside steam-powered felting factories like this, industrial processes create unique textiles through mechanical force and chemical treatment rather than traditional fiber arts techniques. The machinery continues its systematic operation, prepared to receive new wool shipments and repeat the felting cycle that converts raw fibers into dense fabric through compression. Steam rises from the equipment throughout the working day, visible evidence of the mechanical and thermal energy applied to transform textile materials through non-traditional means. Workers complete their shifts, knowing their labor produces material enabling diverse technologies and industries, from precision machinery components to weather-resistant garments and premium hat manufacture. Did you know that felt is produced through mechanical compression rather than weaving? If you enjoyed learning about this unique process of the 19th century textile industry, please subscribe to the channel, leave a like, and, if possible, comment on what surprised you most about felt production. Your support is essential for us to continue bringing this type of historical content. Thank you very much for watching, and see you in the next video.